we're going to highlight the factored form. If you can factor, then, and this connects to chapter 3, factoring it helped us solve equations. Solving equations is when y would be 0, right? Everything we did in chapter 3, we made one side equal to 0 so that we could factor and find out when it was equal to 0. On a graph, that shows up as your x-intercepts. And characteristics of your graph are x-intercepts are going to be really important. Vertex is going to be really important. Y-intercept is going to be really important. And you find x-intercepts by plugging in 0 for y. You find a y-intercept, right? Here it is. You find a y-intercept by plugging in 0 for x. And the general form, if you plug in 0 for x, the part with the a goes away, the part with the b goes away, and you're just left with c. So your y-intercept is probably easiest to find from the general form. But you could plug in 0 for x in a factored form as well. Now, the other thing is once you have the factored form, does it make sense that your axes have symmetry? So I find both of my x-intercepts here and here. Does it make sense that your axis of symmetry is right in between them because of symmetry? How would you find the number right in between, we'll do an easy one, 10 and 20? Does your brain just tell you right away what it is? What does it say? 15. Perfect. Now, what happens if I give you harder numbers? Like, what's right in between 9 and 21? That's harder than 10 and 20, right? How would you find that number right in between? How would you find the number that if it was between 9 and 731? Oh. Right? How do I find out that the number in between that is 307? How do I find that out? What do we call something in between something? Perfectly in between. What's another word for that? Right? I'll give it in context and you'll figure out the word right away. In chemistry, you got 70 on your first test and 80 on your second test. What does the number in between mean? Right? That's your average. Okay? The number in between would be your average. How do you find an average between a 70 and an 80? Besides knowing you can just see it at 75, but if you got 62 and 84, it's a little bit harder to figure out what your average is. Your average is 73 then. How do you find that? Yeah, you add them both up and divide by the number that you have. So they have a formula here for the axis of symmetry. If you didn't know where it came from, it would look very confusing. And you're like, how am I going to remember that? But all that formula for your axis of symmetry is adding up your two numbers and finding the average between your two x-intercepts. So if you had 9 and 21, well, 9 plus 21 is 30, divided by 2 is 15. And sure enough, 15 is 6 away from 9, it's 6 away from 21. It's perfectly in the middle. So if we have the factored form, we can find our x-intercepts, and we can also find our axis of symmetry, which then tells us the x-coordinate of our parabola. So I put a smiley face for knowing the x-coordinate, but we still wouldn't know the y coordinate. So the vertex form, the standard form, that tells us our vertex right away. The factored form tells us x-intercepts right away, but we have to do a little bit of figuring to find the axis of symmetry, a little bit of figuring then to get your x-intercept, coordinate of your vertex. All right. So we're going to go to example 1 now. And they want us to tell all the intercepts, the equation of the axis of symmetry, and the coordinates of the vertex of the graph. So these are the things, we're going to just list them right now, and we'll list them in blue. We want our y-intercept, our x-intercepts, there should be 2 of them, axis of symmetry, well, I said that I cheated because I know that there's going to be 2 of them. Can you see on a parabola, sometimes you have 2 x-intercepts with the U-shape? Sometimes if it's perfectly on the x-axis, you'd have 1. And sometimes if it is above the x-axis going up, it would have no x-intercepts. So sometimes you have 0 x-intercepts, sometimes you have 1 x-intercept, sometimes you have 2 x-intercepts. What does that sound like from chapter 3? The roots. Sometimes we had 0 roots, sometimes we had 1 root, sometimes we had 2 roots. Right? That's the same as chapter 3. In chapter 3, we used the discriminant to find that out. In chapter 4, you could use the vertex and whether it goes up or down to tell that, right? If your vertex is below and it's going up, you're going to have 2 x-intercepts. If it's above and it's going up, you're going to have none. And the only time you have 1 is if your vertex is right on your x-axis. So, we want to find intercepts, axis of symmetry, and vertex. So first of all, your y-intercept. That you can get by plugging in 0 for x, and that is easiest using your general form. So I don't know, maybe I'll put that in brackets underneath. Maybe you would like that. To find your y-intercept, that's the easiest in general form. Do we have a general form? Yes. Why is it the easiest in general form? Because if I want to find my y-intercept, I plug in 0 for x, and I would get 0 minus 0 plus 10. How hard of mental math is that? So we now know that our y-intercept is equal to 10. And you can write it like that, or sometimes people like to write it as a coordinate. So you can write it as either 10 or 0, 10, because that's the coordinate where it crosses the y-axis. The nice thing about the coordinate gives you a hint that x was 0. Right? Your x-intercepts. That's the easiest from the factored form. So, now, the factored form isn't always possible. Sometimes you can factor, sometimes you can't. But if you can factor, so we're going to try now, can we factor this? First of all, is there a common factor? Can you take a 2.5 out of each of those? Yes, you can. I'm going to take a negative 2.5 out, leaving me with x squared. plus 3x minus 4. So that common factor, recognizing a common factor, makes your life easier because now this is a very easy one to factor. It has to be x and x. To get 3, it can't be 2 and 2. It have to be 4 and 1. I need a plus 3, so my 4 will be plus, my 1 will be minus. And so my two x-intercepts, how do we find an x-intercept? You plug in 0 for y. And now, we have a chapter 3 question built into chapter 4. Chapter 3 question was all about solving these. One of the ways that you solve a quadratic equation was by factoring. And if it's factored, you go, well, where is it multiplied? It's multiplied here and here. Draw a line, separate those. Can this factor ever be 0? No, it's negative 2.5. It's never 0. But this one could be 0 if x is equal to minus 4. And this one could be 0 if x is equal to 1. So we now know that our x-intercepts are negative 4, 0, and 1, 0. So again, I'll write those ones as coordinates. Axes of symmetry. Now, I'm going to put that the axis of symmetry is easiest from standard form but easy from factored form. Because your axis of symmetry is always the x-coordinate of your vertex. So if you have standard form, you have your vertex, boom, you have your axis of symmetry. But it's still easy from factored form, because from factored form, it is the average of your x-intercepts. What's the average of negative 4 and 1? You add those together and divide by 2. Negative 3 divided by 2, you would have x equals negative 3 over 2. So you could have found that also by your factored form. So it's easiest from the standard form, but easy from factored form. So if I have standard form, it's super easy, but I don't have the standard form yet. Right? So I have my factored form. Why don't I just use that one instead? So in this case, it's easiest from the standard form, but I didn't have the standard form. So the factored form in this case was the easiest because I didn't have the standard form. So when I say easiest from, that's assuming you can get that. If you don't have that, then it's not necessarily the easiest from. And then the same thing with the vertex. The vertex is definitely easiest from the standard form. But it is easy from the factored form as well. Because we already know by having our axis of symmetry, we know that our vertex, the x-coordinate, has to be negative 3 over 2. So if you have the x-coordinate from your factored form, then you just need to find your y coordinate. And how are we going to do that? I'll do it over here. Well, if you know that x is -3/2, all you would have to do is plug in -1.5 for x. And you could plug that -1.5 or that -3/2 either into x here, or even probably be easiest to plug it into the general form because there's less things that you can do there. So I'm going to go to my calculator. I'm going to go -2.5. Bracket. -3 divided, oh, it did a little fuzzy thing.
-2.5.
Wow, okay. I'm going to go back. Bracket. If you want, you can change it to a decimal because your calculator can handle it. -1.5 squared. Right, I'm rewriting. I'll slide this down. Minus 7.5 bracket -1.5. Plugged in -1.5 for x plus 10. 15.625 or 125/8. Just because I like fractions, I'll keep it at 15.625. I'll write fraction too. So we can find our vertex. If you know the x coordinate, you can plug in that x coordinate into your equation and solve for y, and then you know your y coordinate. That's your basic table of values strategy for graphing. So some of these would have been the easiest in standard form, but because we had to find our x-intercepts, and because we already had the factored form, it made sense to keep going with our factored form to find everything else. Would this have been a nice one to change? You'd have fractions, and then you'd have a -2.5 out in front. So, would you like to see this one changed to standard form just for practice? No. You would like to go to your next one. All right. Questions for this one are 3, 4, and 5. Maybe I'll start with changing this to standard form next class.